Hi, it's Chris with Sanderson Test Prep, and in this video we're going to talk about how to graph polar equations for rose petals. So when we have equations for rose petals, we're going to have to deal with cosine and sine a little bit differently, and cosine tends to be a little bit easier, so we're going to start with that in this video. And the general form that we want to make sure that we memorize is that r equals a cosine n theta. So as we might have already seen if we've already done circles, the value of a is telling us approximate scale, right? That's like the diameter of the circle. And in this case with rose petals, that's going to tell us how far those petals extend out. And then the n theta, n is going to tell us the number of petals. And we're going to be able to use that number to figure out positioning around the origin. So let's take a look at an example of how this works. And the second key piece of information to memorize when you're dealing with rose petals is that if n is odd, it means that the number of petals that you have will be equal to n. If n is even, the number of petals that you have will be twice that value. It'll be 2n. So again, that's one of those things that we just have to make sure that we memorize and that we're careful about, so we don't make a careless mistake to cause that to have us miss an otherwise very complex question that we might have understood just by assigning the wrong number of petals. So first we'll start with if n is odd. So if n is odd, then let's try an example. Let's do r equals 2 cosine, let's do, make that s a little better, but let's do 2 cosine 3 theta. Let's talk about what this would look like. So here, n is odd, which tells us that we're going to have a total of 3 petals. And when we go to draw our first petal, so if we think back to what we know from graphing circles from polar equations, so our first petal, in this case, is going to be, as we might think because it's cosine. Remember, when you think cosine, you want to think x, and so our first petal is going to be along the x-axis, and that value of 2 tells us how far out that petal is going to extend. Now, something that you might see, sometimes you'll see just notation where we put individual tick marks or points along an axis, but it's also quite possible that you see in a class something that looks like this, where you have these circles drawn. It looks almost like, you're looking at a target or something, where you have these concentric circles. And that's not really part of your graph if you see that. So if your teacher draws it out that way for you, that's really just to help offer a guide. So to kind of color coordinate this a little bit better, let me draw out those circles, and I'll draw out those circles in black because those circles are really merely serving as a little bit of a placement guide. So think of it just like your coordinate plane. It's to help us figure out exactly where we're going to place the actual petals that we're drawing. But here these petals would extend out by the value of a, which is 2. So if each of these circles is, a radius of 1 and then a radius of 2 and so forth. So the circles are going to help offer a guide, and you'll see why that guide can be helpful. So here we would have our first petal there. And then for a total of 3 petals, what you're going to do is just divide 360 degrees by your total number of petals to figure out how those petals will be spaced out in terms of degrees. So each of these petals will be 120 degrees apart. And if we think of this just like we're looking at a unit circle, so starting from 0, and the value of 90, 180, and 270, along each of the other axes, going all the way back around to 360. So here 120 will be here, and then, oops, I made that petal a little bit long. Let me see if I can scale that a little better. See, that's why it's nice to have the circles, because it does serve as a helpful guide a lot of times. And then here, from that 120 degree mark, if I add another 120 degrees for the next petal, I'll be down here at 240. And then that's it for my 3 petals. 240 plus 120 takes me back to 360. So that would be the graph for 2 cosine 3 theta. So when n is odd, then the number of petals that you have is going to be equal to n. And for a positive value of a for cosine, like we see here, so when this is positive, like we had a positive 2, that means we're going to start our first petal out to the right like we saw there. Now let's flip it around and try, still with n as an odd number, but let's try a negative value. And let's use this same graph so that I won't have to label as many individual points, because I think we'll see that it's going to look quite similar to what we have here with one key difference. What do you think the graph would look like if we had r equals negative 2 cosine 3 theta? So we're going to anticipate that it's a little bit similar, right? The equation looks pretty similar. So let's think about what this might look like. Here, for this one, so still 360 divided by 3 is 120. So we know the spacing in terms of the degrees between each petal is going to be quite similar. And I'll draw in our guiding circles here just to have them in place. So we'll go out 1 unit, 2 units, and then I'll try to keep these in place as a guide. But what's going to be different? So in this case, if we have a negative value, right? Originally we had a positive 2 as our coefficient, as our value of a. In this case, we have a negative 2. So which way do you think we're going to start? So hopefully, again, we associate cosine with our x-axis, and we might think to ourselves, oh, okay, well then if a is negative, it's going to look kind of similar. But I'm going to have my first petal go along the x-axis to the left, whoops, which is exactly what we do have here. So this is our first petal, and then from there, we're going to measure out 120 degrees in every direction, and you can see that these other petals are going to follow a similar pattern. And it looks sort of like our graph that we had for 2 cosine 3 theta. It's just flipped or inverted the other direction because of the negative. And that's exactly what happens with this. So when n is odd, you're going to start on that x-axis, and then you're going to just have to flip it and start in the opposite direction if you change signs. So if it's a positive, that first petal is on the x-axis pointed to the right. If it's negative, it's pointed to the left. But the rest of the graphing and spacing is the same. Now let's take a look at what happens if n is even. So let's try an example with that. So let's do r equals, and we'll do 2, or I'll change it up a little bit. We'll do 3. Make this one a little bit bigger, but we'll do 3 cosine 2 theta. Okay, so let's see how this changes things. Well, first of all, we know that the number of petals is always for even values of n. The number of petals is going to be equal to 2n, 2 times that value of n. So there would be 4 petals here. And if we start in the positive direction, so here we're going to have, if I put our circles in place to make it a little bit easier for us to follow this as a guide. And the reason that the circles are a helpful guide is that a lot of times, just like we could see up here, a lot of times you're not drawing a petal along a particular axis where it's easy to mark 1, 2, or 1, 2, 3, like we did for that first petal, but the other petals were at an angle out into a quadrant, and so it's easier to measure that distance to come up with an accurate graph if you have those circles in place as a guide. So that's how the circles can be helpful. And if you have a more comfortable time graphing this without the circles as a guide, that's absolutely fine. So for this, we have 4 petals. So we're going to start along our x-axis in this positive direction. Whoops, let me get the color right. So we're going to start along our x-axis in the positive direction. And our value of a is 3. So we're going to go out to that third circle. We go 3 units along that x-axis. And then we're going to evenly space this. So what would be the degrees between each on this? So hopefully we're thinking to ourselves, oh, well, I do the same thing, 360 over 4, which we do. To evenly space these out around the circle, they're going to be 90 degrees apart. And so here, if we know our unit circle well, we can quickly say, oh, okay, the 90 degree marks are ones we can do pretty quickly. We would have our 4 petals around the circle along the axes for each. Now let's try one where we have a negative, and this is why we like cosine so much. So when we're doing our rose petals, if we have cosine and we have an even value for n, well, here's what's fun about that. If n is 2, we're still going to have 4 petals, and if cosine is 3, then I'll quickly draw in our circles as a guide. Sorry, that first one was pretty sloppy, but it's because I think we probably get what we're going to do here. I just want to give us a little bit of a guide so we can draw it out quickly. If we have a negative 3 to start with a positive, we start it out to the right. With a negative, we can think of it as starting out to the left. But here's what's fun about a situation when you're dealing with the cosines and you have the even values. With odd numbers for n, we saw that our graph flipped, right? So we did end up with different graphs when we had an odd number for n, and we changed the sign of a. When a went from positive to negative, the graph inverted. But for an even number for n, if you start out to the left here, well, because of the symmetry, when you have an even number for n, it's going to work out that you're actually going to have petals in the same places. They're still 90 degrees apart. And if you measure 90 degrees, 90 degrees, 90 degrees for your 4 petals, you'll end up with the same graph. And so that's what's really nice, that we really like about the positive and negative values for a when you're dealing with even values for n in your cosine graphs for your rose petals. These graphs are the same. So it really makes things a lot easier when dealing with even values for n, because you don't have to worry about the sign on the a in front. The symmetry makes it work out the same every time. So make sure you take some time and really understand how it flips when you have an odd value for n, because that's an important take-home message. And the most important thing is that we memorize these equations like the back of our hand, because that's what's going to allow us to draw out the rose petal cosine functions. And in our next video, we're going to take a look at the rose petal graphs when you're dealing with a sine n theta. So stay tuned and check out that next video. Thanks for watching.